I'm Mario Márquez, and today I'm going to explain you the design pattern called Singleton. The Singleton design pattern is applied to make sure that only one instance of a class is created, and it provides a global access point to the object. This pattern is useful when only one object is needed to manage actions across a system. In other words, the class can control its own instantiation. This pattern also hides its own constructor, making the class not callable from outside of itself, and it defines a public static operation that returns the instance of the class. The UML diagrams for this pattern are these ones. The one in the left is the general one, and the one in the right is the one that I'm gonna be using in my example. It shows us the private static variable, which holds the only instance of the class. It also shows the private constructor. With this, the class cannot be instantiated anywhere else. And also, it has this public static method, which returns the single instance of the class. Let's see this implemented. This is a no thread safe singleton, when it only checks if the instance is null to be able to create it. There's another way to create it, the thread safety singleton. This way creates an object backlock to lock it before checking if the instance is null. This other way is called double locking thread safety. It checks if the instance is null before and after the lock to create a double check and then create the instance. In this example, we're creating a single class called Singleton Test Withdrawal Manager. It has the same things that the double locking way. In this case, the getInstance method is receiving an int value and a string name, which are going to be the name of the user and the value of its withdrawal. Then creates the instance and assigns the values respectively. In the main, we can see the creation of the threads. We're gonna run it. If we see the same user and value, the singleton was correct and only one user made the withdrawal. If we see different users and values, two singletons were created. We see the same values, which means that the singleton was correct and only this user made the withdrawal. After seeing the implementation of this pattern, we can see that none of the solid principles apply to this pattern, mainly because it doesn't have subclasses, it doesn't allow to inherit from it, it doesn't implement interfaces, and it always depends on the concrete class to get the instance. And finally, the MVC. This is a design pattern that specifies that an application consists of data model, presentation of the information, and control of this information. This is achieved thanks to three main elements. The model, which contains the application data and it doesn't have logic. The view is how to present the data to the user. It accesses the model data but doesn't know how to interpret it. And controller. This is between the model and the view. It listens to events on the view, then calls a method on the model, and it is reflected in the view. This design pattern is most used as a part of the creation of user interfaces.